Hello everyone, welcome to the NPTEL online certification course on fundamentals of food process engineering. We are continuing with the topic of mixing and agitation. In the last class, we have discussed about what is the importance of mixing and agitation, what are the different purpose and what are the cases where we use this. We have started with the solid mixing first, and then we have discussed mixing index and mixing process. Now, today we will start from the mixers for dry powders, and then we will move on to the other topics, that is mixer for cohesive solid, liquid mixing and power requirement for liquid mixing. So, first we will see the powder mixers. So, as we know that the characteristics, the bulk flow characteristics of the liquid and the solid are very different. That is why the mixer used for solid material and for the liquid material is totally different, and the liquid mixing part some extent we might have seen in the in your fluid mechanics class as well. So, here we will see first the mixture for the solid. One such mixture for the powder is tumbling mixtures. There may be horizontal drum, double cone type, V cone type, Y cone type and also like cube type. These are operated in batch mode, being partially filled with the solid. So, as we need to mix it thoroughly, we need to give some free space to revolve it completely and to have all those mechanism as mentioned, that the convective, diffusive or shear mixing. So, therefore, we cannot fill it completely for mixing, for a certain degree of fill is desirable. So, these are operated in batch mode, all such horizontal drum or tumbling mixture, because as the name suggests we need to perform those tumbling operation here. Tumbling mixtures are run at a fraction of the critical speed required for centrifugation with a practical maximum speed of about 100 rpm. Okay. So, we can see that the speed is not very high, very low rpm we run these, and such mixtures may have baffles, baffles fitted to the inner wall, which helps to lift the solid, or alternatively may be fitted with a plough to assist the convection. So, the barrels are like, if you have this is a tank, or this is kind of a mixture that you are using. So, in the wall there are baffles. Okay. So, this will help in lifting of the solid that is there in the chamber. Some portion of the filling will be there. So, the lifting will be initiated, or that will be easier if you use the baffles there. Okay. So, these are the tumbling mixture. Then we will see horizontal cylinder kind of mixtures will be there. Double cone blender. The double cone blender consists of two cone shaped sections, typically with an angle of 45-degree slopes. So, here first one is the horizontal cylinder. We can see that there is a horizontal horizontally oriented barrel is there, and it is rotating based on that central shaft, and thereby it is initiating the mixing. So, most of the there is likely to cause diffusive mixing, where the particle is constantly diffuse into the interparticle pores. Okay. Then double cone blender and V cone blender. The double cone blender consists of two cone shaped section, typically with 45-degree slope. We have the diagram will show you, and then V cone blender. These are consist of two large diameter pipe sections cut at 45 degree and welded together to form a V. Y cone blender, in the same way the Y cone blender has the third section. So, with that V cone there is another section that extend the volume of the blender in a bisectional direction with respect to the other pipe sections. So, we will see the geometry here. Double cone type is this one, okay, and there is a spiral blades are also there, which will help you to initiate proper mixing, okay. And there is V cone type. So, V cone type is this one, and these are also can be revolve freely. There is a Y cone type mixture. There is a one extra cylinder added to V cone, and this will also give some extra volume and better mixing. So, these are the tumbling mixtures, different kind of tumbling mixture used for solid mixing. Now, the ribbon blender. Ribbon blender, this initiate the convective mixing. If you remember, that was also one mechanism. Okay. So, it consists of a trough and shaft with two helical screw. There is a trough, this one, and there is a central shaft is there. This one is the shaft with two screw. This is one and this is one. Okay. Two helical screw is there. So, if you can see in this diagram also, it is clearly visible that the two different screw are there. One is rotating in the inner side, another is the outer side. So, inner helical ribbons moves the solid slowly in one direction as the convective motion or convective mixing takes place, while the outer one moves it quickly in the opposite direction. Okay. So, inner helical ribbon moves the solid slowly towards the forward direction in one direction, where the other moves the quickly in the opposite direction. So, because of this change in the movement, the mixing will be done. There is a resultant movement of the solid in one direction due to the difference in peripheral speed of the ribbons. So, this is how the ribbon blender operates. Now, radial mixing also achieved due to rotational motion of the ribbons. Radial mixing, that is in a radial direction also mixing is being done as associated with the movement of the ribbons. Now, mixing is strongly convective and segregation is far less pronounced than in the tumbling mixtures. Okay. So, here so that means it helps in proper mixing, segregation is not there. Then dry applications, this is used for the cake and muffin mixture, flour, bread improvers, cereals, trail mixes, snack bar, spices and herbs, tea and coffee. So, all these cases these application will be there. And when the dry blending food products, relatively small amount of liquid may be added to the solid in order to coat or absorb coloring, flavoring, oil and other additive solution. Okay. So, these are the application where this the dry mixing will takes place. Next is the vertical screw mixture. So, we can see here that the cylindrical or cone shaped vessel are there, okay, either cylindrical vessel or the cone shaped vessel can be there, and in that the spiral screw will be there. So, the screw will be either centrally mounted as in the figure 1, or this is set in a this is orbit around in a slanting side of the conical vessel, and it is moving with a orbiting around a central axis or moving around the central axis. Okay. So, these are called the screw mixtures, vertical screw mixtures. Materials are lifted from the bottom, are then exchanged with the material on the way up. So, from the bottom, because of the screw motion, the material will be lifted to the top, and then again it will be mixed with the materials. This kind of mixtures, vertical screw mixtures, are useful for mixing small quantities of additives into large masses of the material. Okay. So, when a small fraction of one component has to be added to the larger fraction of the other component, then we need to use this one, so that a thorough mixing from the bottom to the top layer will be there, and this will be even more suitable if we use the orbit mounted or orbit kind of screw screw mixtures. So, it will initiate the better mixing. Next type of the mixture is called fluidized bed mixture. The resulting turbulence of passing air through a bed of particle material causes material to blend properly. Okay. Because in fluidization, what we do is there is a perforated sheet or cloth or tray is there, through which we send the high velocity air, so that the particles which needs to be dried or need to be mixed properly, that will become in a suspended state, and thereby the proper mixing will be there. So, because they are kept at a suspended or fluidized state by application of high velocity air, we call it the fluidized bed mixture. So, materials to be mixed have to be relatively fine and fairly narrow in their size distribution, as well as not too cohesive, because if they are a fine particle, then only the proper fluidization will be easier, and if they are cohesive, then also they will not be exposed properly on the fluid stream, and the proper mixing will not be done. Mixing times required in fluidized bed are significantly lower than those required in conventional powder mixture. Okay. So, mixing time required in fluidized bed are significantly lower than those required in a conventional powder mixtures. Okay. So, this is because when we use the fluidized bed, so each and every particle these are in fluidized state, and from the all faces it is open to mix with the other composition, but that cannot happen when we use the powder mixture, conventional type, tumbling type, like that. So, then what happened, that to get an uniform composition, time requirement will be more, because if with every instant very small fraction will be come in contact with the material, and the uniformity to take the whole zone will be of uniform composition. So, that extent mixing will take a longer time. Next we will see the mixtures for cohesive solids. Now, the property of the cohesive solid is again different from the property of the free flowing solid material. For that we have used the tumbling mixtures or fluidized mixture, but we cannot use those for the cohesive solids. The mixing elements cannot generate the flow current. Mixing elements cannot generate the flow current, because if we use any this kind of a mixture that is used for the solid particle, so even in the solid also they generate some kind of flow, but this cohesive solids, because they have very high viscosity and cohesive in nature. So, therefore, they cannot generate flow currents. High power consumption, this is one significant thing that is needed for the cohesive solid, and the types will be change can mixer, kneaders, dispersers and masticators, mixer extruders and mixing rolls. Mixing is by combination of low speed shear, smearing, folding, stretching and compressing. So, here we can see that there are many individual applications that combinedly use in the mixing of the cohesive solids. Those are the low speed shear, smearing, folding, stretching and compressing. So, those might have seen the dough making process in the or you have seen the Farinagraph analysis. There we use this kind of a shear mechanism to knead the dough properly. So, there is a kneader blade and a very particular shape of the kneader blade is used so that it can give a proper shearing action to the material, okay, and eventually make it of an uniform composition even if the moisture content is very high. So, first we will see the change can mixture. The principle is change can mixture work by the relative motion of the blades and the can. So, the types is pony mixture and beater mixture. In the pony mixture, the rotating agitator carries several vertical blades positioned near the vessel wall. The can is driven by a turntable in a direction opposite to that of the agitator. So, we have seen that there are lot of blades are there that is mounted on the top section. Okay. So, the rotating agitator carries several blades. So, these are rotating and the blades are also rotating with that rotor, and they are positioned near the vessel wall. The can is driven by turntable in a direction opposite to that of the agitator. Okay. So, they are rotating in a opposite direction. So, that this opposite direction there will be very less space between the blades and the periphery or the barrel inner side. So, in between that small gap the dough will be sheared, okay, and because of this shearing action the mixing will takes place. So, in that category another is the beater mixture. So, in that beater mixture what happened that there is a can or vessel which is a stationary one and agitator has a planetary motion. So, there is an agitator, this is kind of a beater mixture is there where there is a stationary vat is there or stationary can is there and there is a agitator which has a planetary motion. So, this is called the beater, okay. This is called the beater and there is a change can, there is a cart, there is a planetary gear which helps in rotating this arrangement. So, the agitator has a planetary motion and beaters are shaped to pass with close clearance over the side and bottom of the mixing vessel. So, at one side, at one peripheral side and also at the bottom it may have some kind of geometry like this. So, at the bottom and the periphery it will be utilized for shearing of the dough material for proper kneading. Then kneader mixture, working principle is that some kneaders achieve their mixing action by squashing the mass flat, folding it and squashing it again. Okay. So, this is a common mechanism. If you see kneading action in home or any small scale industry, if you have visited, so you know that first the sheeting thing is done, okay, or squashing is done, and then this is rolled, okay, this is rolled properly, and then again squashing or stretching forces will be given. Okay. So, these are the normal action of the hand by which we knead normally any dough, and the same action has been simulated using a particular kind of blade. So, that will do the act of kneading. So, other tear the mass apart and shear it between a moving blade and a stationary surface. So, two kinds of kneader we may get in a normal practice in the industry. One is called the kneader, where the mixing action is by squashing the mass flat, folding it and again squashing, and the other method is that shear it between a moving blade and the stationary surface. So, it consists of two contra rotating arms which fold and shear the material, and the arm rotate at a differential speed nearly 3:2. Okay. So, the speciality is two contra rotating arms is there which fold and shear the material. Cooling is provided commonly. So, we can use a jacketed kind of system where if the excess heat will generate, so that can be cooled immediately, and large energy requirement. So, for kneading operation, the energy requirement is a bit high because these are highly cohesive material, and to make it in a to make it in a movable or foldable condition, or to stretch it properly, to squash it properly, lot of energy requirement is needed. Now, coming to the different kind of blades of a kneader mixture, we have seen that one kind of blade is sigma blade. This is used for general purpose kneading, and edges are serrated to give a shredding action. So, with shearing, here we are providing shredding action also. That means shredding means we tear them in many parts. Okay. So, these are the sigma blades. Then S type double Nabben fishtail blade. These are effective with heavy plastic materials and develop high shear force, this S type blade. The other type is Z type disperser blades. So, what it does? The heavier and develop high shearing forces. Z type disperser blades, these are heavier blades and develop high shearing forces. So, the cases where high shear force is required, very cohesive kind of sample, we can use this. Disperse powders or liquid into rubbery masses. So, that is another another application of this Z type of disperser. It disperse powders or liquid into rubbery masses. So, these are called the kneader mixture. As I said, the sigma blade is the first figure. This is the sigma blade, okay, and the second one, which is the S type double Nabben fishtail blade. This is this one, which is look like an S. So, this kind of double Nabben blade are there, and the other which is used for very viscous material. So, this is the Z type blade. Okay. So, we have seen that in a dough kneading in a farinograph, either this sigma blade or Z type blade, these are used normally, and here is also one kneader mixture. The picture is given where these two blades are attached, and there is a trough where these are rotating, and in between there is also one deviation or demarcation is given. So, that one blade is moving in one trough and the other blade is moving in another trough, and they are rotating in a differential speed and making the mixing properly. Okay. So, here we will stop and we will continue in the next class. Thank you.